Chapter 7 P Block Elements 12 Signs Part 2 Physical Characteristics. Hello students, I am Madhusina, your chemistry teacher. Watch my YouTube videos, like and subscribe it for further notifications. In this video, we will be studying some of the general physical characteristics of P block elements. You know that P block includes elements from group number 13 to group number 18. For convenience, I have written down few groups on the board. Group number 14 includes carbon, silicon, germanium, tin and lead. 15 is nitrogen, phosphorus, arsenic, antimony, bismuth. 16 is oxygen, sulfur, selenium, tellurium and polonium. Group number 17 is fluorine, chlorine, bromine, iodine, astatine. And group number 18 includes helium, neon, argon, krypton, xenon and radon. Now, group number 15. In this chapter, we will be studying elements from group number 15 to group number 18. Group number 15 is popularly known as nitrogen family because nitrogen is the smallest member of the family. Group number 16 is also known as oxygen family. This oxygen family is also known by the name chalcogens. This chalcogen is a Greek word for brass and association of sulfur and its compounds with copper. So basically this word chalcogen means ore forming compounds. So group number 16 is also known as chalcogens. Group number 17 is popularly known as halogen family. Again, this is a Greek word. Halo means salt and genus means producing. That means they are salt producing compounds. Group number 18 is popularly known as noble gases. We also call them as inert gases or rare gases. They are noble or inert because of their completely filled configuration. They are chemically non-reactive and is found in very less percentage in the atmosphere. As we already know, the first member of the family is smallest in the family and is capable of showing anomalous behavior. They show a totally different type of behavior as compared to other members of the family. The last member of the family is the biggest member, the oldest member in our family, which we can compare it as our grandparents. They are just like our grandparents who die and disappear from the family, but they still remain a part of our family. After death also, our grandparents are a part of our family. In the same manner, these elements, they are radioactive in nature. They have very short half-life. They disintegrate. They continuously emit radiation, disintegrate and disappear. So it is very difficult to study the chemistry of these elements because of their radioactivity. Now, let us study the physical properties one by one in detail. If we compare the electronic configuration of these elements, for group number 15, the general electronic configuration is Ns2Np3. For group number 16, it is Ns2Np4. For group number 17, it is Ns2Np5. And for group number 18, it is Ns2Np6. If you look at the electronic configuration, you will notice that as we move from left to right in a period, the number of electrons are increasing in each atomic orbital. The orbital remains same. So every time the electron is placed in the same orbital, but the number of valence electrons are increasing. From this we can make out that here and this NP3 is an half filled orbital. So therefore it is having a stable electronic configuration. Here NP6 is completely filled. So this is also having a stable electronic configuration. From top to bottom in a group, the number of valence electron remains same. That is why we say that the chemical reactivity of all the elements present in a group is similar, because they have same number of valence electrons. If we consider the second periodic property, that is atomic size or atomic radius, we define atomic radius as the distance between the center of the atom to the outermost valence shell or orbital. Now, as we move from left to right in a period, we already have studied that atomic size decreases because the electrons are increasing with the increase in atomic number. But every time the electrons are being added into the same shell, the distance between the nucleus and the outermost shell remains constant. As a result, the nucleus has a strong force of attraction for the outer electrons, and a contraction takes place in atomic size or atomic radius. So we can say, as we move from left to right in a period, atomic size decreases. On the contrary, when we move from top to bottom in a group, every time the electrons are being added in the new shell or new orbital with the increase in atomic number, the distance between the nucleus and the outermost electron goes on increasing. As a result of this, the atomic size increases from top to bottom in a group. Now let us make a comparative study of the atomic size in all these groups. We are moving in a period. So group number 15 is having a smaller atomic size as compared to group number 14. Group number 16 has smaller atomic size as compared to group number 15. Group number 17 is having the smallest atomic size in their respective periods. And why it is having like this? The reason for this is that it readily wants one electron, right? The number of electrons here to reach stability required by these elements is only one. The nucleus exerts very strong force of attraction, and there is maximum contraction here. So halogens, we can say halogens are having the smallest size in the respective periods. So that means if we talk about this period fluorine, then here chlorine is having the smallest size compared to others. Bromine, iodine, like that we can say. If we talk about noble gases, they have the highest atomic radius in their respective periods. Highest. Why the highest atomic radius? Because they are completely filled and stable. So because of the completely filled configuration, there is inter-electronic repulsion in group number 18. So to avoid repulsion, the electrons try to move away from each other, and as a result, the atomic size increases in case of group number 18. So we have seen in the period. Now let us talk about the group as you move from top to bottom in a group. atomic size increases. So when we are moving down, slowly the atomic size is increasing because the number of electrons are increasing, and every time the electrons are being added into new shell, the distance between the nucleus and the outermost shell increases, resulting into increase in atomic size. If you notice group number 15, you will find that from nitrogen to phosphorus, there is increase in atomic radius. Then arsenic to bismuth, we find a small increase in atomic radius. But when it comes here, you notice a sudden decrease in the atomic radius. So slowly, gradually, we have a general trend that as we move from top to bottom, atomic size increases. But gradually you see when you are moving down here you find that in case of bismuth, in case of polonium, in case of astatine, in case of radon, there is sudden decrease in atomic size. What is the reason for this? The reason for this can be attributed to a phenomena known as inert pair effect. What is this inert pair effect? How do we define this inert pair effect? The reluctance or hesitation of inner electrons to participate in chemical reaction is known as inert pair effect. And what is the reason for this hesitation of electrons to participate in chemical reaction? It is given to a very poor shielding effect shown by F electrons. F electrons are showing a very poor shielding effect. So there is minimum repulsion between them. And since there is minimum repulsion, the nucleus is able to attract the outer electrons. And because of that, there is a sudden contraction in size instead of increasing. So smooth increase in the atomic radius is not observed. When you reach here to the last member, suddenly you find a sharp decrease in the atomic size. So that is being attributed to this phenomena of inert pair effect.